Hello, Adrian.
Hi there.
Hi, Leo.
Good morning, guys. This is Leo. Can you guys hear me?
Yes, we
Yes.
can.
Yeah.
Hi,
Hi,
Leo.
Leo. That's good.
Hi, Neil.
Hi, Aid.
Hey, George.
Good to see you all again.
Hey, Dwayne.
Hello.
Hello, Dwayne.
Hi.
Are you on a bike right now?
Yeah, just finishing up.
Hello, Dwayne. I haven't seen you for ages.
Yeah. Well, if you can't tell, I'm on my stationary bicycle.
I
I've
think
got-
it's fairly obvious.
Welcome, everybody. Today is Access Lunchtime, and we're going to be talking about parsing JSON data using VBA. And today's session is a follow-up from last month's session. So if you didn't see last month's session, there is a YouTube recording of it available at this point. So you might want to put that on your to-do list to kind of get more depth for what you're going to be seeing today. So the first presenter today is going to be Neil Sargent, and he's going to talk about his findings when using the VBA-JSON library that we mentioned last month. And he's going to review what's missing or lacking and what improvements he made to the library. So, Neil, go ahead and take it away.
This is a follow-up, really, to last month's presentation. We looked at the VBA-JSON library by Tim Hall, also known as the VBA Web Tools. The JSON library is one part of that. And this was following Maria's presentation of actually using the API the Graph API on Microsoft. She was using the VBA Web methods to get data down from Microsoft Graph. And we're going to be doing more of this API work as the years go on. And in VBA, there aren't any built-in tools to do this. And we've found that the VBA Web tool was a very good method to do that. Leo, who's going to present later, knows a bit about alternatives that are out there as well and some of the pros and cons. And he's going to present some information on that later on. So what we looked at with initially Maria's API work was that we use a get method to go and get data from a URL, and that data is downloaded using, typically these days, JSON. It's almost certainly going to be either JSON or XML that comes down when you use these APIs. JSON is dominating really how the methods that are used. So we felt that Access developers could do with a bit of information about how to deal with this JSON data coming from the web. Last month's presentation looked at what JSON is, and when we get the JSON into our VBA variables, we handle it as a set of dictionary objects which represent JSON objects that have been downloaded, and collections objects in VBA which represent arrays that come down from the JSON. We don't use VBA arrays, we use VBA collections to manage the arrays. They work very similarly to arrays, but they have the added advantage that they've got an index that you can address them by name. This month, I'm going to just present a little bit of information about how we took the VBA tools from the web, which we showed you last month and showed you where to download them, and what I found, in fact, using them, putting them into practice in real-world application, and what I found that I needed to tweak to make it work. We had a few questions about people had downloaded and it hadn't worked, and we might have had some clues as to what might have caused that. And also, one of the other things is that there's not a lot of information on how to actually use this stuff to post data up to the web. There's an awful lot of APIs where you're fetching information. We demonstrated the Google Books API last month. And I might get a chance to show you a little bit about how we post data up to a web from VBA code. Okay. So when I downloaded the VBA web tools from the internet, I found that I needed to make a few tweaks to them to make them work for my application. And I'll just describe to you what those tweaks were, and then we'll look at two or three of them and which I've actually got some code for, which I can release to you, which will show you how I overcame some of the shortcomings that I was faced. Not initially, but after I'd done this application, I'd used this VBA Web Tools to actually get my Access database talking to a web API. One day, all of a sudden, the user reported, oh, it's all packed in. It's not working anymore. It's just refusing to connect. And what it turned out to be was Microsoft decided that from now on, everyone ought to be using TLS 1.2 as their minimum security level for connecting across the web. So they changed the Microsoft HTTP libraries to default to using TLS 1.2. And the web client software I had was using the original TLS, I think, TLS 1. And so it was all failing. It wasn't particularly clear why. It took a while to work out why. And the fix was quite easy because all we had to do was change it to say, by default, use TLS 1.2 as transport. So that's where something which was working broke because something moved on in the technology, basically. I needed to actually communicate with the people who were providing the API in order to actually work out how to use their API. And when things went wrong, was it my fault because I was asking wrong, or was it their fault because they were answering wrong? So I needed to put in there logging of everything I asked them so that it was absolutely clear to each of us what I was asking of the API, right down at the byte by byte level, seeing what the JSON string is going up and down the internet were. So I put in some logging. That was quite easy because in Tim Hall's, he'd already got logging to show you what was happening with debugging. And what I did was I put it in so that it saved it to a table for me in Access. So I had a permanent log of what I'd been doing. So when something failed, we could look at that log and see what we'd been talking in terms of right down at the byte by byte level. Similarly, I was logging the responses that I got. So we had a definitive log in an Access table telling us what had been requested and what came back. His end, it was just a standard function on Unix. It's logging them anyway. But from our point of view, I needed to check that I was actually asking the right questions. It was usually me getting it wrong. Fair enough. There's another problem I faced was that within the JSON library, there's this standard option, which basically is no escape solidus. It sounds very, very difficult, but what it is that it's optional in the JSON definition as to whether or not you put an escape in front of a backslash. That's a solidus character. And the API I was talking to actually needed the escape solidus as the default. So I just changed the logic, really for my convenience, so that by default, my version of the VBA-JSON always escaped the solidus unless I told it not to, rather than the other way around. I needed to otherwise tell it to escape the solidus. Now that really is just a tweak that was very much application specific to me, so I won't go any further on that. Another thing that I had to do was an optional parameter to expand JSON strings. We showed you how within JSON, when you get data back, arrays or objects might come back, or individual discrete values like strings, dates, and integers. And this particular application that I was using, rather than returning a JSON string with a JSON object within it, they actually embedded the JSON within a string. So from the JSON point of view, what came back from a string, but what was in the string was more JSON. So the JSON parser didn't automatically recurse down through those objects because they weren't objects as far as it was concerned. They were strings, so it had nothing else to do. So I had to tweak it to put another parameter in there to say, when you see one of these string values coming back rather than an object, then jump into that string and carry on recursing. So I had to add a parameter to make that happen because I didn't want it happening in all my JSON work, otherwise it would cause chaos. And as a result of that, those embedded strings might have actually had a null in there to say, actually, I haven't got any further JSON information in this string field. What was happening then was that I was calling JSON and asking it to look at an object, but the object just said the word null, which was JSON telling me there isn't an object. And that caused the standard JSON to fail because it was expecting an object and it was getting a null. And so I had to put extra support in there for this tool. Now, when I've looked back at this in some detail, I can realize that this is very much application specific because the particular API I was doing, I think what it was doing was a little bit weird. Rather than giving me a full JSON return, it was giving me a JSON return, and some of the strings in there were further JSON. So they were using JSON not only for the actual API to talk up and down the net, but they were embedding JSON objects as strings in the data they were using. So I think this business about the support for null was a little bit application specific. So I'm not going to go into great detail on that either. Then what happened was that my application, it was synchronizing my Access customers with my applications customers so that we were both talking about the same customer list and using the same customers for each of our discrete applications. And that started to fail. All of a sudden, things started to fail. And it turned out that we had some customer names with some Unicode characters in there. And that's when I discovered that JSON didn't actually support Unicode characters. And what was happening was I was sending up someone's name with a umlauted character in it or something like that. And the umlaut wasn't making it through. So when I said, compare customers, it basically lost my Unicode umlaut on top of the U. And so it never compared. So I kept on sending it and sending it and sending it because I thought he wasn't listening. So I had to go and extend JSON to support multi-byte characters. And that I'll show you in some detail in a few minutes. And then the other tweaks that I did were really just error handling within the code to make it compatible the way I do my error handling so that the messages came out consistent in my application and so on. So these are the tweaks. And I think if you're getting in a library, you can expect you might need to do some of these things, particularly the style type things. But a couple of these things I think are much more general and would be useful to people. So I'll show you those in some more detail. So the specific things I'm going to look at, as it stands, the library doesn't support Unicode characters, and I'll show you a solution to that. As it stands, it didn't support TLS 1.2. Sorry, it could support TLS 1.2, but I was making a default connection, and Microsoft decided that the default now needs to be more secure. So I would have had to go back into all my applications and say, go and use TLS 1.2 as a standard connection method. So rather than go to all my applications that use the JSON library and tell them to ask JSON to use TLS 1.2, I decided to make TLS 1.2 the default for JSON so that whenever I went through the web APIs, it automatically tried to use TLS 1.2, which is Microsoft was saying you need that because that's now the standard for the HTTP request, which is what's actually doing the communications with the web. And the other thing I had to change was this support for null, but I'll gloss over that at the end and show you what that really meant. Let's have a look at these support for multi-byte Unicode characters. Now, I'll show you what happens here. I've got a form here. Now, what I've got for my database is the raw current release of the VBA web library. Now, last week, we presented the VBA-JSON library. Let me just see, which one is it? This one, VBA tools. And we showed you the VBA-JSON library. Now, the VBA-JSON library is just for doing the JSON side of things. The VBA web library is for doing much more things, and that does the actual API requests that we previously saw Maria show us how to actually use an API to go and get data, read it down as a response. That response is in JSON, so put it into the JSON converter and turn it into something that we can use in our VBA. And last month, we specifically showed you the VBA-JSON library because that's all we were talking about, the JSON, and how it converts JSON strings into VBA dictionaries and collections. This time what I'm showing you in my demonstration is the VBA web library, and if you like, that's a superset. It's got the VBA-JSON within it and a lot of other things, which are all the HTTP requests for posting or getting information across the API. And so what we're looking at here is the recently downloaded latest version of that, which I think is 4.1.6 of that VBA web library. And it consists of the client to actually make connections to an API, request or post data, the response to actually receive that data back, and then the helpers library, which is what includes the VBA-JSON code to convert that response into something usable in VBA. Part of that web helpers and part of what you have to do is you have to translate all your data, all your string data, into web-friendly URL encoded data. So here we've got an example of a string we might be wanting to send up the internet. And what we have to do is we have to URL encode it by changing all the spaces into %20s. And you'd have seen this before, just using the web in general, that certain characters get escaped into special characters so that binary things can be sent over the internet. And the URL encode function, which is in the web helpers, takes your raw string and converts it into URL escaped encoded string so that the system at the other end can receive your binary data. The URL decode works the other way. When they send the data back from the API, it's URL encoded to get it across the wire, and we have to decode it back into strings in order to actually then process it in our code. And the processing we do is we put that decoded string into these JSON libraries and dictionaries. So that's a typical thing. Now, if we go and look at if there's certain control characters which the web wants to use to control the API, things like commas, question marks, percentages, they have to be escaped by turning them into these % characters. And you can see that this comma character here has been converted into %2c. And all the spaces have been converted into %2. And what we've got here is I've got a raw piece of text there, which I'm just picking up from a table, a test table that I've got here. I'm encoding it using the URL encode function inside the JSON helper libraries. And then I'm decoding it back again to show that having encoded it and decoded it, it still looks the same as what I sent. And here's the rub, because if we put a Unicode character in there, all of a sudden it fails. This time I've included a Unicode character. In this case, it's a Greek sigma. We'll be familiar with it as being sum of. And what has happened is that we failed to encode it properly. And in fact, what we've encoded it and turned it into is a question mark. So when it gets up there and comes back again, it's coming back as a question mark. Now, you'll be familiar with these question marks because whenever you do anything in Unicode, in the immediate window, when you're debugging VBA code, you often see these question marks because the actual VBE environment doesn't support Unicode. It only actually supports ANSI characters. So when you have Unicode characters, they often appear as these question marks in your code. And in fact, because of that, I can't demonstrate this with debugs. I've actually got to do it in text boxes which do support Unicode because the actual characters all show as question marks in VBE anyway. We can see that that has failed, but some of the characters which we want to send up, now here we've got a couple of characters which should be encoded, but they haven't. So we've actually sent them up the wire unencoded. So not only has JSON failed to encode some characters, or rather it hasn't understood the character, so it's sent it up as a question mark. This time it's actually not even realized it's a Unicode character and sent it up as a Unicode character. And that's a no-no because that's going to break things on the web because those accented characters shouldn't be in this encoded string. So it's quite serious that this isn't working because if you come across anything with any Unicode characters, then it's going to fail. So what I'm going to do now is show you the code which is actually the code which is actually doing that VBA. And first thing we find is we look at our URL encode function, which we know is failing because it's not sending the data up as here's the URL encode function. And we look through it, see, well, what's it doing wrong? First thing we see is a big comment here from Tim Hall saying, oh, I haven't implemented this. It doesn't work for non-ASCII characters. So this isn't a bug. This is a unfinished loose end that's in the VBA library. It's not something that they've done wrong. It's something that they haven't implemented because they didn't need to, they haven't had to, but they recognize it's a problem and left clues in there as to what we can do about it. And what I've done is I've followed those clues and done something about it so that my code has enabled me to carry on working and sending up these Unicode strange characters. What he says here is that what we need to do is actually encode this Unicode character into 2 or 3 UTF-8 bytes and send them up as a sequence of bytes. Well, let's think about it. Our normal characters are in the range 0 to 255. But as soon as we go past 255, it's no longer a byte, it's a word. And it's using 2 characters to represent the character that we're displaying. And in fact, all of our Unicode characters are doing that. In VBA, we're using Unicode, and all our ASCII characters are only using 1/2 of the double byte word that Unicode strings are stored as in VBA. But this time we're actually using the higher byte and saying we want to send up character 425. Sigma is the character 425. But ASCII, or rather ANSI, is a 1 byte thing, so the 255 don't fit, and that's what's gone wrong. So the first thing we have to do to fix this is to, just incidentally, I'll just quickly show you on the decode, he's also put a thing in there saying, oh yeah, and when it comes back, you've got to work out what to do with the non-ASCII characters coming back. So here's one I prepared earlier. This is the database that I actually modified the code to deal with these Unicode characters. So URL encode. Let's just look at what this code is actually doing. First thing it's doing is basically taking our text string and it's going to return an encoded string which has been encoded according to URL encoding rules. It does other things. It does other types of encoding. The default is URL encoding, and I'm not going to go into all the other options that it supports, but it's got other forms of encoding in there as well. So first thing it does is go into the string and reads it 1 character at a time. And then the character that it's read, here's where it goes in, and for each character in the string, let's actually look at the character code of the string. And by using the ASC character, it's limited itself to only returning a single byte character. So the first thing we have to do is to change that into the AccessW function, which will actually return a 2-byte word for each character. So that stops the, in our case, our Sigma character, instead of coming back trying to squeeze 425 into a byte, can only take a maximum of 255, it's coming back as a word, which allows us to actually get the proper 425 number back from the character. Having actually then got our number in the range now, instead of 0 to 255, it's in the range now
65536.
65536. Yes. It comes back as plus or minus, but it's in the range 0 to 65,000 basically. So the encoding carries on with all the values up to 255 as they did, and then when you get to anything bigger than 255, we hit this to-do thing, and now we've got our number, which we've read as 425, our Sigma character. What we've got to do is encode it into UTF-8. Now, UTF-8 is an encoding method which basically says we know that it's the beginning of a sequence of bytes which represents a bigger number. That's the essence of what it's doing. The easiest way to do it is ask Windows to do it for us, because there's a built-in function which will actually just do this for us automatically. That built-in function is basically wide charter multibyte, and it's an API function which says, basically, you tell me what you want it converted to, and give me a Unicode string tell me how many bytes there are, and I'll give you back a multi-byte array and tell you how many bytes I've given you. That's as simple as it is, apart from it's an API function, and we all know that they aren't simple. What's more, they're doubly unsimple because this is using Unicode strings. And when you use Unicode strings in the API, you have to pull some special tricks. So what those special tricks are, I didn't do this work. I went off and found someone cleverer than me that already done it. And I came up with this particular solution. So this solution is very useful because it tells us not only what it's doing, it actually tells us how it's doing it, why it's doing, and a bit of background work. In the same way as we used ASCW to return the word long version of the character code, we can actually use, in theory, a function called strconv to convert a Unicode string into bytes. But they point out here why that's not a good idea, because basically it doesn't work. What it does is it takes shortcuts. And instead of just returning a Unicode string, it says, if you ask for A with an accent, instead of giving you the Unicode A with an accent, we'll give you one that happens to fit in our character set that we're using anyway. And what comes back is actually the wrong character. It looks right. It is in fact the right character, but you asked for Unicode 425 and you ended up with Latin character something else. So strconv can't be used, and they explain that, and they also explain the function to use it. We were talking a little bit earlier about the fun and games of doing that in 64-bit. They've also got the 64-bit version of it. Let's have a look at the function itself. I've imported these functions into a new module called modUPF. And in this function, basically what we're doing is we're taking our Unicode string and we're returning a byte array. We're first of all checking that the string isn't null, and if it is, we're making sure that we exit with no bytes. Then what we do is we use this yCharter multibyte function, and the yCharter multibyte function tells us how many bytes it needs to return the string. And then we call it again and say, okay, allocate a buffer to receive them, return those bytes. And what comes back then is an array of bytes. But there's another thing in here which is a bit weird, and this is to do with the way that we actually send Unicode strings to API functions. When we send a string to an API function, with the old ANSI strings and the old version, the ANSI version of the API, we can actually put a string as a parameter to our API call, and VBA comes in and says, oh, he's using strings in the API, and it does a bit of marshalling for us and turns that string, sends that string over. So it does things like the null terminator and everything for us, rather than us having to do it. And it also does that with Unicode strings. We've got Unicode strings. What we'll do is we'll turn his Unicode string into a API string for you automatically. But the trouble is that messes all this up. So you have to pull another trick, which actually says, forget about the fact it's a string, listen to what I'm saying, and send an array of bytes, and get that array of bytes from my string. I'm not going to go any further into that, but there is another very, very good article on this by our friend Philip Stiefel. He'll actually, in this video, explain to you, there he is, the whole business of how these strings are marshaled by the API. If you watch this video, it tells you exactly what's going on. It makes you understand how this is working. Because one of the worst things about 64-bit conversions is if you're working with these Unicode strings, because they don't behave as you'd expect them to. I'm not going to go into the pros and cons of that. I'm just telling you that this is the information that I've gleaned in order to solve this problem. The link is on here. So I've called this function which converts our string into UTF-8 array of bytes. And then, having called the function, I then, for each of those bytes, put a percent in front of it. So, job's done. What we've done is we've taken our Unicode string, we've used CHRW to recognize that it's outside the normal 1 byte range of 0 to 255. We've taken that character, which we now know is a Unicode double byte string. We've used the API via this helper function to turn that into a byte array, and then each of those bytes, which are now UTF encoded bytes, we've put our % in front of, which is our original encoding intention. So we've sent out 2 or perhaps 3 bytes to represent a single character as a sequence. So if we look at that now, our Unicode character has been turned into %6, %A9, whereas before it was coming out as a question mark character. And you can see now that when we decode it back again, we're getting our Unicode character. So just looking at that, those characters which weren't being encoded and were slipping through as invalid characters on our web connection, those have both been properly encoded as well and decoded back to what they were again. In fact, the Unicode range is not even just 16 bits, it's bigger than that. And there are Unicode characters that we can't even handle in VBA because they go outside our CHRW double byte word range that we store our strings in. But because we need basically 16 bits to represent all our characters for the word, but the URL encoding needs 1 or 2 of those for its own control character coding, then some of our large Unicode characters actually come out as 3 bytes when they're encoded. And here's an example. A smiley face. Can't tell you offhand what character it is, but it's a higher value above 65,000, above the 16 bits. And what we've got then is a 3-coded one. And as you can see, that's encoded and come back as well. So our encoding and our decoding. So the decoding, this time what's happened is that if we go to our decode function, again, Tim has put us a to-do in there saying this needs to be done. And what we've done is we've said, okay, we now know that we've got a % character, but we've got a problem now because some of those Unicode characters are coming back as 2 bytes, some of them coming back as 3 bytes. And we don't know until we've read them how many there's going to be. So what I've done is I basically said, well, I'm not going to get all complicated about it because I've got a function here, UTF bytes to string, which will convert them for me. So what I'm going to do is every % character I see, including the spaces and the simple ones, the single byte ones, I'll pass them through the function and that function can convert them all for me. So what I'm doing is I'm going through this code, and if I see a %, I carry on jumping 3 bytes at a time until I see a normal character that's no longer got a % in front of it. What I'm actually reading and converting, I'm not only converting those 2 characters, what I'm actually converting is all of those characters, including the space that I could easily do myself either side, because it's only by reading them all that the UTF that I know whether to expect 2 or 3 of them. So I've asked the API to just do it directly for me. So what's come back is our multi-byte string. We tack that on. Job's done.
Yeah, is it possible for you to explain again that bit about how it recognised the % after the 20 wasn't part of the 20? So you've got the first one there. In that one you've got highlighted.
Right,
How
in the UTF.
How does it recognise that as being a single character, whereas the following 2 are considered to work together?
Right. For a start, if there's a %, it's going to be a 2-digit character because they're all bytes. So they're all single bytes. So if I see a %, I know it's going to be in groups of 3.
Yes.
Okay. As I said to you, when I'm decoding, personally, I don't know when I read that byte whether I'm going to see 2 or 3 or how many I'm going to see. And in fact, I think if I saw a whole string of them, I wouldn't know whether they were groups of 2s or groups of 3. I'm sure I can tell because the first one of any set is not going to have the first bit set because of the encoding, but it's much too complicated. So what I've decided to do is just send the whole damn lot through to the API and say, you do the spaces for me as well, and let it work it out.
Right. Okay. So you can't.
The API has decided for me that that is space, sigma, space. The way it's worked it out is when it sees a character, okay, if it's a 2-byte character, it's always going to have the first character is going to be first bit isn't set. That's part of the encoding standard for UTF. So it knows that it started a sequence of 2 or 3, and it therefore will say, well, the next one that I see without a space is the next sequence. So that's how it will determine if it's a 2-byte or a 3-byte sequence. So the other support I've made, default support for TLS 1.2. This one is simply a case of there is an article there which explains the need for it, which is where Microsoft decide that we're going to change the default to TLS 1.2. And then in the code, the affected module is actually this WebClient module. And all I've had to do in here is go in and add an extra option to say, when you're setting up your options for the HTTP request, this is the actual making the connection across the wire, use TLS 1.2 as a default. So I've just put a piece of code in there which basically tells it to include a request to use TLS 1.2 when it sets up a default connection. Now they can be overridden. There's all sorts of parameters in web helpers to say that you want to use different standards, but I've just changed the default setting here. So that's the only other change I've made to the code. The last change is about this support for null. And as I said briefly before, I'm not going to get into the real detail of this because this turns out to be an application-specific hack that I've applied because of the weirdness about the API I was using. And when I did that hack, I found that it was actually putting null into string values where it was telling me were JSON strings. Well, null isn't a valid JSON string. It's a valid JSON value, and it can be in a string, but I understand that a JSON string has to be either a curly brace object or a square brace array. And just null on its own, I don't believe, is a valid JSON string in its entirety. It may be, but the fact of the matter is that you can't represent that as an object. And our dictionaries and collections are coming back as objects. So I had to put in special handling and said, well, if I see one of these nulls, return an empty object, return nothing instead of a dictionary or collection. And I had to change it to say, if you see nothing, put an empty object in. So I haven't done the code on that because I think that that was specific to the way I was working. Okay, so I've done some links here. You've got the VBA tools that we've been talking about from Tim Hall. There's a link there to the Unicode string conversion functions. And there's a link there to Philip's brilliant video on dealing with the Unicode strings in API calls. I'll pass you over to the DBguy.
Yeah, thanks a lot, Neil. This is great. Okay, Leo, if you want to take it away.
First of all, I'd like to thank Neil for this very fascinating deep dive into Tim Hall's library. In contrast, my topic is just going to skim through the surface. Just like everybody else in here, we're all dealing with the XML. About 7 years or so ago, when I started seeing that there are more JSON API results coming out, that's when I started looking into this. I believe that's when I first saw Tim Hall's library. So in this case, we've already discussed that library a lot, and we wanted to know, hey, are there other possible libraries out there that we could use? And that's what I'm going to discuss, okay? Basically, I'm going to talk about 3 available options. They don't all have official names, so I'm just going to call them one JSON converter, and then JSON parser, and a JSON interpreter. And I'm sure there are more options out there. Like I know Colin has one, and maybe if you go to an Excel forum, you might find more. So let's go ahead and go through these. The first one is JSON converter, which basically is the same as I'm calling the VBA-JSON or TMOS library. Again, it's available on GitHub on this link. I haven't used it in a while, so I had to take a look. The last version that's on there right now, I can see is back in 2019. But that wasn't the version I think that I tried before. It might have gotten some updates. As Neil mentioned, even Maria mentioned, if you're using the VBA web tool, this VBA-JSON library is included in that. The thing I do not know is if they had updated this, how do they update the copy in that VBA web? So
he updated VBA web with the latest.
Right. Okay.
That's one of the updates to the VBA
Right.
web. So it's being pushed through to the same.
Okay, thanks. When I was doing this, I didn't use the VBA web. When I request an API to a web server, I just did my own HTTP request. So I was only concentrating on the VBA-JSON library. So I knew if that got updated and I go there and grab it, it'd be exactly what I was getting. But anyway, the way you would use this VBA-JSON library is you would declare obviously your object variable, and then you would set it to pass your JSON string with the parse.json method. That's how you would use it. Now, correct me if I'm wrong, but this is how I use it. Okay, some of it characteristics. Again, it's very popular. A lot of you guys use it, and a lot of meetings and demonstrations use this. However, when I first tried to use it, it failed to parse some of valid JSON. And I'm sure some of you are aware of this. And I also had initially problems with speed, so I had to go check on that and see why is it doing that. I was frustrated with that. Also, the way it is written, it requires reference to Microsoft scripting runtime because it's early binding. And this image on the right is basically showing all the functions available in that module. And this is just the VBA-JSON one, okay? This is not the VBA web. Like I said, I had problems with using that, and there were some issues that other people were also having with the JSON converter. So I had to go looking for a replacement. And I found JSON parser, which is more powerful than the VBA version because this uses the built-in Microsoft JavaScript engine. I'm not quite sure where that's coming from. Perhaps when you install Windows, which installs Internet Explorer, and the JavaScript engine is installed, right? So I don't know. But anyway, it's already in the computer, and that's what this uses. You guys know Jack Leach. You can find his article and the actual function on his website. The reason why he created it, because he described in there what the problem with the VBA-JSON was. And this was a solution also that he realized could be used. The way that you would use this is first you would initialize the JavaScript engine. You would then set your declared variable to pass your decode JSON string method. George has a question, but the last time I looked, I didn't find the timing.com parser. Is this current? Yes, because when I did the slides, I went to that link, and that's where I saw that it's still there. Now, I think in one of the forums, I answered a question about this, and I posted the link, and they told me, it could have been John Clark, was it you who said, hey, the function in that article is incomplete? Maybe it is. I think there was some function missing. But otherwise, I can provide that if you guys don't have it. Okay, using this, I find that it's cumbersome because it's very simple. You see, it's only got these functions in it because it's relying on the JavaScript engine. So with its simplicity, I find that it's very cumbersome to use and to work with. However, it does parse all valid JSON, not like the other one. So that was the first obstacle that I had with the first JSON converter, and I had to use this one because I don't have to worry about it messing up all valid JSON input that I give it. However, because it's using the JavaScript engine, it is vulnerable to security threats like JavaScript injection, things like that. So if people know you're using this particular method, and they could potentially mess with your system and get in. Now, the way Jack wrote this application or this method, library, whatever, he uses late binding, but it's for Microsoft script control. So you don't have to worry about references. Since I had issues with failing JSON parsing and then hard to work with, although it's good, and plus I wasn't so sure about that vulnerability, I had to go looking for some more possible alternative, and then I found this one, JSON interpreter, I call it. This one is object-based because it uses a class module. It's also available on GitHub, and the way you would use it is you would declare a variable and instantiate it with your class module, and all you got to do after that is pass your JSON string to its JSON property. And that's it. Now, like I said, I like this because it's object-oriented approach, which means I get IntelliSense when I use this, which is very helpful. As you can see, it has all of these methods within the library. And I've highlighted this one particular method exists in red because that's my favorite. Comparing to the previous two libraries, if you are dealing with a JSON with optional items in it, optional levels, optional objects, you'll just get an error when you try to access it. You either do error handling or something to overcome it. In this one, I can just go, hey, is this thing available? Does it exist in this JSON string that I received? And then I can deal with it or not. So I really like this library. It also works extremely fast, and it parses all JSON. Okay, now let me caveat that bullet. If you'll notice, I said in the first slide, the JSON converter, I said it failed when parsing valid JSONs. But then on the JavaScript engine one, I said it parses all valid JSON. In this one, the subtle difference, I said it parses all JSON. This is just based on my experience in my testing. If you have an invalid JSON, but the invalidity of it is like an extra comma or an empty object or whatever it is that makes it an actual honest to goodness invalid JSON by standards, this will not have a problem with it. It will still return the objects as long as it makes sense. I don't have an example, but if you give it a simple JSON structure that has an extra bracket at the end or extra comma in the end, which makes it an invalid JSON, but yet values in between, it would still give it to you. You will only get an error when you get to the part when you're trying to access an object that it's not supposed to be there. So that's a particular issue that maybe some of you will not be able to, or I don't know, you just have to deal with it or think about it. But I just realized this because obviously when we deal with APIs, you get pretty much a valid JSON, hopefully, from the web developers, right? So I never really ran into this issue. I just realized this when I was preparing for this presentation, and I was just testing it a little bit, and I realized, oh, wait a minute. So that could be a plus or a minus. It depends. Again, this particular library uses late binding for Microsoft scripting runtime, so you don't have to worry about references. This is a basic comparison of the syntax because this is what most people have issues with, just like in the XML days when you had to worry about XPath and how do I access certain levels of deep objects. So using the same JSON result that we get from Google API that we used last month, the Books API, and using the same example that Neil gave before where we're trying to find the author of the book. So using the JSON converter like he demonstrated before, you take your object and use the parentheses notation and you go to level by level items and then the first object in that level and then you go to the next level volume info and then try to go to the author's listing in that and then the first listed author. And that's how you'd get J.K. Rowling's, right? But also, as mentioned before, since this is using a dictionary or collection, it is one-based indexing. Now, JSON parser, which is basically the simple but cumbersome thing that uses a very powerful engine, you end up doing all of these methods. First, you get the object, then you get the property of that object. But if you're going several levels deep, then you're getting a lot of object properties first. Now, it does have a method called getObjectType, so that actually in your code, you won't do this. You would try to find out what is the type of the object, and then you could either use getProperty or getObjectProperty. But basically, this is a simplified syntax version where you'd say getProperty, getObjectProperty, and then you end up with your JSP, which is your object, and then the items, the volume info, authors, and then you go get your JK Rowling result. But one thing to point out is this is zero-based indexing compared to the JSON converter or the JSON interpreter. Now, my favorite is the JSON interpreter. Like I said, if I type in the JSI, which is my JSON object, I hit the dot, and I get IntelliSense. And then I use the item method, and then I put in the path, my items, my first object in there, my volume info level, my authors listing in there, or array or whatever list, and then the first object in there. Now, after that, though, you're not done. You put another dot, and you use the method called VBA variant. So it would return a VBA readable value of that object. Kind of like, I compare this to like if you're using C, for example, you use .toString, something like that. So whatever object it is, in the end, you end up saying, hey, give it to me in VBA form, something that VBA can understand. That's basically the way syntax works. Now, as I said, there was some speed issues I had initially, so I had to just quickly check this again. And this is a very non-scientific speed comparison. JSON converter, for example, is not slow, but not really fast. So it's fast enough, as I say. JSON parser, which is the JavaScript one, is very powerful, but it's slower than the VBA libraries that we have available. And again, JSON interpreter, because it's a class module. Once you instantiate it, you're done, right? You assign the JSON string to the JSON property. I don't think it really gets parsed at that point. So you're done until you access the object. That's when the power comes in. I was just trying to see, hey, how fast would it parse a JSON string no matter how large it is? This is basically my general conclusion, and it's very non-scientific. I didn't time it or anything like that. Maria pointed out last function missing from Jack's web. Did you also get some of stuff from the thread? I'm not sure what, but hey.
What I notice when you look at what they're showing here is the last function they have is this public function get keys. I don't even know if that's the last function. There might be other functions after this, but this function is not complete. It looks like it has just the beginning of it.
Well, this is all the functions that is available to it. The decode JSON string, get keys, get object property, get property type in its script engine. As I said, when you first use this, you would initialize the script. So that's the last function in here. And then you would get
those are the ones. So it's just that get keys is in.
Okay. I have that. Or I could ask Jack.
Well, so I think what Crystal was asking was in the UA thread that you were talking about it, is the rest of that function listed in that?
I have to check, but looks like Crystal gave the link in the chat, so maybe somebody could jump in and also check.
So before we go any further here, since it is 1:02 and we can keep continuing and answering questions, I want to be respectful of the people that do need to leave, at the hour point. I just want to mention for March and April topics, stay tuned to both the website and email. For March, I think the normal time for this is at the same time as the MVP conference. And then April, just stay tuned and I'll let you know. All right, I'll let you go ahead and finish up, Leo.
Okay, so Neil asked a very good question. He says, does this do JSON encoding as well as decoding? Okay. First of all, let me preface that by saying my usage of parsing JSON is come from querying a web API to give me a JSON result. I don't have right now or never had any reason to pass a JSON string to a web API to do something with it, right? I always have like, hey, give me information about a client financial information about a transaction, it's all asking for JSON strings. So I never worried about encoding to a JSON, but like he demonstrated before, you have convert to JSON and also on the VBA-JSON one, the JSON converter, it has buffer append. I forgot what it is, but okay. The JavaScript one, it does not. It just decodes the JSON and it gives it to you. However, on this other one, right, you have JSON append null, append number, append record set, append string. This one does have it, okay? You could build your own JSON on this one. And the way you would then return a string out of it is out of the JSON property. The JSON property get over here. I don't know if you guys can see my mouse moving. And that's how you would do it. I never had to use it, but you can with this one for sure.
Okay, so if anyone else has questions, I think we've covered most of them in the chat, but feel free to put more questions in there, or you can come unmute at this point and ask your questions of either Leo or Neil. And thank you both for your presentations today. They've been quite educational.
All right. Thank you so much.
Just saying to Leo, what I've found is that the API I was working with was using JSON to actually present parameters for the get functions. So you were actually encoding into JSON the parameters for what you were asking for. So you needed to encode JSON just to actually get functions back.
I understand. And that is true. I have also run into some API that says, hey, I need these parameters, the name, the last name, for example, the beginning date, the end date, in JSON format, which is fine. I can do that in my HTTP request. What I was talking about by encoding JSON is grabbing your table information and converting it into JSON. I never had to do that. That's what these things are for. I believe this VBA-JSON library, you would pass it a table and go through the library and then convert your table structure with its parent and child relationship into a JSON string. I never have to do that yet. Okay. But building a JSON request, I can do. And I don't have to use this library because that's very simple. It's not in the table. You just apply to it, concatenate a string that says, hey, open bracket here, and then go delook up my token in a table and pass it on. That's all.
Yeah.
So I think there was a question earlier by Colin wondering exactly what you meant by problems with null. Colin, did you get that question answered?
Maybe I misunderstood what the point was, that JSON values are either strings or numbers. You can't even have dates as such. So they should never be null. And you will get frequently the situation where there's a missing value, and that's just normally omitted from the JSON file.
That's not correct, actually. If on JSON, on the actual JSON definition, the actual string null, the word null in lowercase without quotes around it, indicates a null value. It is supported by JSON.
Right, I stand corrected. The time I was working on this is 8 years ago now, so I'm rusty, to put it mildly.
The API that I was working was only transferring strings. Everything was a string. Dates were embedded in strings, numbers were embedded in strings, and JSON objects were embedded in strings. And that was the problem I had, because the library didn't therefore recurse into them, because it wasn't an object, it was a string. And what was happening was, when they had one of those, he called it a JSONified string, when he had one of these objects represented as a string, he then put pure JSON value null without any quotes around it if it wasn't there. And that's what blew the top off the API that I had to fix.
Thank you.
Yeah, thank you, Colin. If there's no further questions, I've got some example code sitting here, which I'd be prepared to show you, which actually uses JSON parsing to post database records up to an API. We've seen an awful lot of getting data from the internet, but this is an application which is actually doing a two-way exchange of database tables. And if anyone's interested, it will take a few minutes, but I'm quite happy.
I'm fine with that.
I would love to see that, Neil. I love what you've done so far, Neil, and it's really obvious that all three of you have just put in so much time on this. It is really smooth, and I look forward to seeing whatever else you're going to show us.
Okay.
You can go ahead. So, thank you.